All right, now that that's fixed. Up next we have another box plot, and it says the box plot suggests about 25% of the quarterbacks in the boys football league threw fewer than what number of touchdowns? Again, what I said before is that this line right here is Q1, this is the median, this is Q3. What do they mean? Well, Q1 means the first quartile, and quartile comes from the word quarter. Quarter obviously means 25%. What that means is this line is telling you where 25% of the data is less than or equal to. So, in other words, 25% of quarterbacks threw fewer than 7 touchdowns. The smallest 25% is in this line right here. And then if you wanted to know if it said about 50% of quarterbacks, that means the answer would be 10, because fewer than 50%, or sorry, 50% throwing fewer than what number? Well, 10 is right here, and 50% of the data is less. Another big thing to think about box plots is that the size does not determine how much area is in there. So in other words, I can draw you a crazy box plot that looks like this, but the idea is this small bar is where 25% of the data lies. This bigger chunk is where 25% of the data lies. This chunk, 25% of the data lies, and this line, 25% of the data lies. So just be aware that the size or the width of a box plot has nothing to do with what percentage of area is underneath. What tells you what percentage of area underneath is, are you looking at Q1, the median, Q3, or all of it? Because here 25% of the data is less, here 50% of the data is less, here 75% of the data is less, and so there you go. Alright, now we have a stem and leaf plot. It says the average lifespan of 18 common species of turtles are shown below, and then they also give us a 5-number summary. And the question is, according to the 1.5 IQR rule, how many outliers are in the data set? And the 1.5 IQR rule is a typical question that you'll see in the AP exams. This is definitely a good one to know. First question is, what is the IQR? And that is the value of what's in the third quartile minus the value in the first quartile. So 40 minus 24 is 16. So 1.5 times 16, 1.5 IQR is going to be 24. Let me just double check. Yeah. So the 1.5 IQR is 24. The question is, how do we determine where an outlier is? We need to find what is Q1 minus 24 and what is Q3 plus 24. And Q1, if you look, there's 24. So what's 24 minus 24? It's actually 0. And then what's Q3 plus 24? 40 plus 24 is 64. And we call these upper and lower fences. Essentially what it says is, as long as a data point is within 0 and 64, these are not outliers. But if something is outside, that makes sense, then they are outliers. And so we can see here, the max value is 138. That one's definitely an outlier. Also, this value 75 and 77, those are outliers as well. So there are 3 upper outliers that are greater than the 64, and there are no values that are less than 0. So 3. Oh, but I should read the question carefully. How many low outliers are in the data set? So the answer is 0. There are 3 outliers overall, but all 3 of them are high outliers. So be careful that you're reading that question. All right. Up next, it says a small accounting firm has 4 accountants who earn a different salary between $50,000 and $60,000, and a 5th accountant who works part-time and earns $10,000. The firm decides to get rid of the part-time accountant and keep the other 4. How will getting rid of the part-time accountant affect the mean and median? Here's the essential idea of this question. You can imagine the salaries like this. There's someone who makes a very small amount, around 10K, and then these people are making anywhere from 50K to 60K. There's a lot of distance in between. If we think about this, the median of the data set is median would probably be somewhere, actually it'd be exactly that value, whatever that value is. Also, just know that this is just a representation of the problem. In fact, all 4 of these people could make the exact same salary. We really don't know, but I'm just giving you a clue here. So the median is the middle value of the 5 currently, and that means the mean, if you think about this, this is like a skew left distribution. Most of the data points are over here. There's one small little tail over here, and so that means the mean is going to be somewhere around here before the data point's removed. However, after you remove the data point, now the median's here, but now the mean is probably here as well. And so if we look at those and compare them, the median's barely moved over, but the mean has shifted greatly. So that kind of gives us the clue to the answer. Both the mean and the median will increase, but the mean will increase more. Another way of phrasing this problem, the idea that AP is really getting at here, outliers will always affect the mean more than the median. So that is something that you definitely want to be aware of. Outliers affect the mean more than the median. That also means outliers affect the standard deviation, and that also means that outliers don't affect, if they don't affect the mean, in other words, they don't affect the second quartile, the outlier is not going to affect the first or third quartile either. All right. Up next, it says if the mean is 3, find the number of puppets Marco made. This isn't even really an AP question, but oh well. So if we have 1 plus 4 plus 3 plus something, all divided by 4, because we have 4 puppeteers, and we know that the answer is 3, the question is, what is that last missing value? Well, multiply the 4, add all those up, so we add all these up, this is 8 plus x. If we multiply the 4, we get 12, and so that means the answer must be 4 after you subtract. Gosh, I hope I'm right. Okay. Find the interquartile range of the data below. Remember, if you're going to find the interquartile range, you need to figure out where Q1 and Q3 are, and that means you're going to have to count up all the data points. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. So 10 data points. First, the median would be the average of the 5th and 6th value, because if you're going to split this in half to find the middle, median, you're going to have to just go 5 and 5 and then average those 5th and 6th values. And then from there, how do we then find Q1? Well, Q1 will be the 3rd value, the value right in the middle, and then Q3 will be the 3rd value right in the middle. So if we count 1, 2, 3, the 3rd value is actually 0. And for the 5 highest values, if we start on the other end, 1, 2, 3, the 3rd value is 4. And so the interquartile range is the difference between these two. So what is 4 minus 0? 4. All right, up next they want to calculate the standard deviation. If it's been a while, the standard deviation formula on the AP reference sheet is going to look like this. Or they might actually write it like this, xi minus x bar. So what that means is it means each data point minus the average of the data points divided by the amount of data points minus 1, all in a square root. So there are 12 values here. That means n minus 1 is 11. You're looking for 11 at the bottom. So we've already eliminated it just down to either A or C. And the last part to notice here is you can see those dot dot dots means they're just skipping writing all of those values minus the mean. But A is correct because A squares. All right. Last but not least, which interval contains the median? Again, if we count up how many there are 10. We kind of went over this in the last example. 10 means you're going to have to find the 5th value and the 6th value in order and then average them. So the idea is here's the first value, the second value, the third value, the fourth value, the 5th, and the 6th. So the 5th and 6th are in between 15 and 20, which means when you average them, you're going to get something between 15 and 20. So that's where the median will be. And that's it. We did it. All right. So good luck with that assignment. Hopefully your questions are similar to mine. If not, be sure to take a picture of them and ask me